That is why I love you. If you are the focus, she might forward.
How are you doing?
Okay, good morning, class. So, Abrazak, can you unmute and talk so I can make it
Good morning,
so you
ma'am.
can control the class? Yeah, Abrazak. Is he online? He's not online yet.
Yes, ma'am.
Okay, who is the assistant rep? Okay, Bridget, I'm going to make a co-host, so you have to control the class for me. Anybody that comes, you make sure.
Ma'am, yo.
Okay.
Mute yourself. Bridget, mute yourself.
Abrazak, can you unmute and talk so I can know you? Unmute now. Don't mute until I make you co-host. Abrazak. Where is Abrazak now? Hello, Abrazak.
Ma.
I said don't mute yourself until I make it the co-host, please.
Okay, ma.
Okay, please control the class. Thank you. Okay, good morning, class. Okay, there's something a prof brought to my attention that was not in the slide. So she had to share that slide and said I should make sure you guys are aware of it so that you will not be surprised. And said, we're not taught, and it came out in it. So I'm just going to talk on slide like 3 or 4 slides that was omitted in that previous slide. So at the end, I'll share this recent slide with you. So it's all about glow stick chemistry. Okay, glow stick is what we normally experience. Okay, I think we use it severally in functions when something happens and you see light glowing. So let's go to understand what are the chemistry behind glow stick. Remember, they said everything is chemistry. So that glow stick, there's a chemistry behind glow stick. Now, anthracene, remember we're talking about polyaromatic hydrocarbons. Anthracene is a polyaromatic hydrocarbon that is available in dyes. If you look at the previous slide, when we are talking about the uses, you start hearing dyes and pigments. So, and this anthracene is available in colored dyes and pigments. Okay, different colors that you see as dye or color pigments that are not natural, okay, are anthracene, and some of them might be natural. Remember, these natural products. Okay, so and some of these they have this ability fluorescence. That fluorescence is the glow you see. Okay, there's some of the these dyes that you normally see whenever you apply them in something like lip gloss. You see that they start glowing. So these are the presence of anthracene. So now, what is this glow stick? Glow stick is a reaction called chemiluminescence. This chemiluminescence is a chemical reaction that produces light without heat. Remember, in that glow stick, there's a light, there's illumination, but there's no heat. So that's how we call them. It's a chemical reaction called chemiluminescence. Okay, so the reaction of glow stick is called chemiluminescence. So you have to understand that, number one. And this glow stick has 3 components. The major component there is hydrogen peroxide, phenyl oxalate ester, and fluorescent dye. The fluorescent dye is what you're talking about that might be from an anthracene. Okay, so now what happened in glow stick? I want you to understand most of the things there are not in the slide, but I want you to understand that. Number one, the chemistry of glow stick is called chemiluminescence. Chemiluminescence. Okay, that's the chemistry of glow stick. And this glow stick have 3 major components. Remember, it's like chemical. Then when you mix them together, they produce dye. They produce light, and that light is always colored. So now, why you have different color of glow stick is because of different colors of dye. Okay, we have, if you can see, look at the slide, you can see we have different colors of glow stick. Now we have red, we have orange, we have all the colors you can think about. They are in glow stick. And what infers difference in color is just because of the presence of dye, that fluorescent dye. Remember, glow stick is made up of 3 components: the hydrogen peroxide, the phenyl oxalate ester, and the fluorescent dye. The fluorescent dye is what induces the different colors you see in glow sticks. Okay, now we continue.
Please, ma.
Okay, now
Those components. Sorry, ma. Please. Those components you just mentioned. Can you repeat it, ma, again? The 3 components, ma.
the 3 components are hydrogen peroxide, hydrogen peroxide. I don't like noisy class.
Wait, I will not take that. It's a C. No.
Can you please? This class needs to be controlled. I don't
Please
like
put on
noise.
the mic.
Please, co-host, make sure the class is always muted. When people enter the class, I keep telling you, whenever you enter class, okay, it is very civil for you to mute yourself. It means it's part of telling yourself that I'm civilized, right? I'm educated, I'm well groomed. Don't allow people to mute you, okay? It doesn't represent you well. Now, I said that glow stick is a reaction called chemiluminescence. So this is a chemical reaction that produces light without heat. It may show little or no heat at all. So the chemistry of glow stick is called chemiluminescence. And this glow stick has 3 components: hydrogen peroxide, phenyl oxalate ester, and fluorescent dye. These are the 3 components of glow stick: hydrogen peroxide, phenyl oxalate ester, and fluorescent dye. Now, this fluorescent dye, like we talked in the previous class, that polyaromatic compounds are useful as dye and pigments. So an anthracene is available in colored dye and pigments. So when you talk about this fluorescent dye, you talk about the presence of this anthracene in different colors. So that's why you have different colors of glow stick, because of the different colors of dye. So if the glow stick you're looking for is red glow stick, it means that in that fluorescent dye, the color of dye that will be there is red. So now, how does this glow stick work? That's what matters. What is the chemistry behind the glow stick? Now, listen very well. Now, this glow stick, you can see now, is like a container. If you look at it from the slide, you can see that it's contained in a tube, and that tube has something like a glass that bears this liquid. So what happened is that now when you break this dye, when you break this liquid, this hydrogen peroxide is going to mix up with oxalate ester. Remember that oxalate ester is where that fluorescent dye is contained. So when there's a mixture of this oxalate ester that contains the dye and hydrogen peroxide, okay, they're going to form an intermediate compound. They're going to form an intermediate compound, When you go through this tiny write-up, you're going to see that. Okay, they're going to form the intermediate compound. This intermediate compound is highly unstable. Okay, it might be possibly be 1,2-dioxatenedione. Dioxatenedione. 1,2-dioxatenedione is in the slide, but it is very tiny. So this 1,2-dioxatenedione is very unstable. Okay, so whenever it comes, remember when a compound is unstable, it's going to break down. So this intermediate is going to react with the dye in that particular oxalate ester and become excited. When it becomes excited and relaxes, whenever a compound moves to an excited state, it will certainly relax. Whenever it's relaxing, it emits light. That light is the glow you see. Let me come again. You have this liquid, okay? So when you break them up, the oxalate ester is going to react with hydrogen peroxide. At times, what you can do is that when you break it, you start mixing them together. When you mix them, it means that you are agitating the reaction. So then when they react, they're going to form an intermediate that is highly unstable. And this intermediate is going to start breaking down. When they break down, they're going to react with that dye. That will be an interaction with the dye, which will cause this mixture to be excited. And when it relaxes, it emits light, which is the light, the glow you see. So that's the chemistry of glow stick. Number one, you must know what is this glow stick. This glow stick is actually the light that is emitted when hydrogen peroxide mixed with oxalate. That's just that. How does it go? That's what I'm talking about. So when there is reaction, they're going to form an intermediate, which is very unstable, which is going to break down. So in the version of breaking down, it's going to be excited, relaxes to emit light. That is the glow you see. Okay. And what are the uses of glow stick? Why do we need glow stick? What are the uses of glow stick? Glow stick is what we use in everywhere. It's being used in recreational night driving. It's used in military. It is used in band conducting. Okay, it's in entertainment parties. So glow stick is what you see everywhere whenever they are having programs. See, there is a glow. There's a light that glows. And number one, we are always advised not to try the chemistry of glow stick at home. Okay, because it's not something you can try on your own, except you're a professional. Okay, so glow stick, in summary, is a reaction called chemiluminescence, which occur when hydrogen peroxide reacts with ester, that is phenyl oxalate ester, in the presence of a dye, which is called fluorescent dye. Remember, it is that dye that brings about that fluorescent. That's why they call it fluorescent dye. When the reaction occurs, and there is reaction with that dye, that reaction with the dye that causes excitement, and when the excited molecules relaxes, then they emit light, which you see as a glow. So that's what I really wanted to say today. And finally is what are the uses of anthraquinone? Anthraquinone is one of the components. Let me finish. I'll give it time. Anthraquinone is one of the components we see in aloe vera. Okay, whenever you're doing phytochemical reaction, there's a phytochemical we call anthraquinone. Okay, so this is one of the components of aloe vera. It's seen and is very useful, but it has some side effects. There are some people that must not take aloe vera because of the presence of anthraquinone. You can see some people, when they take aloe vera, see that there is purging them because of this aloe vera. High doses can cause diarrhea. And that's why pregnant woman is not advised because of this presence of this anthraquinone. And people that are of blood type O's and also not meant to take aloe vera, okay, because they can react to it negatively. Okay, so aloe vera is good because of the presence of anthraquinone, but it's not for everyone. And if you must take it, make sure you use it in low concentration. But aloe vera is the presence of anthraquinone make aloe vera very useful in skincare industry. It has anti-aging properties and is also good for hair. Okay, so you should know at least 1 or 2 uses of aloe vera without anthraquinone. So when they're talking about anthraquinone, what will come to your mind is aloe vera because it's most active component of aloe vera. It has anti-cancer properties. Okay, it's also useful as anti-aging. It has hydrating properties. That's why it's useful as anti-aging. It also has some sunscreen potentials, and it's very good for hair growth and prevent it has antimicrobial properties and such like. So ask your question. Somebody was
So my
asking about
question,
Shina's
yes,
question.
my question is
Oh,
that
you're
all
muted.
these stick
I will explain that.
that they use for banga, they call it banga. All those banga that bring forth
What time is
light
the
and
class?
all of that during this festive period, man. Are they examples of
No,
glow stick as well?
banga is from the description of glow stick. Banga is not a glow stick. Banga emits light. Okay, glow stick is something that glows.
Let me search for it.
It glows. It glows. Banga emits like glow is like a liquid. It's form of a liquid you mix together. We're talking of hydrogen peroxide is not powder, it's not solid. So it's different from banga. Glow stick is not banga. You can see the way it brings illuminescence, like it glows inside the whatever you put. There was a glow. It's not like a light. It's not like a spark. It's a glow. So what you
Okay,
need to
man.
know,
So
what's the chemistry of glow stick? What are the components of glow stick? So how does it work? That's all you need to know here about glow stick. Ask your question. Now, glow stick for you to now, if you look at this particular stroke, this particular slide, you can see this is all the components are there. This is phenyl oxalate and fluorescent dye in a solution, right? This other one is hydrogen peroxide. All of them are in. But when you break it, you're inducing interaction. They all have different layers. You can see them. The tube have different layers. One layer for phenyl oxalate and dye, another layer for peroxide. Now, they are not activated. Then, when you break them, that's when you activate. You can see this one has been broken. When you break it, now you're causing this reaction to occur. Then they are activated. That's when they're activated. So when they are, it's like a tube that contains so many components. So when you break the tube, you cause a reaction to occur. So when that reaction occurs, what happens is that they form a compound. Okay, this compound is what we call that is an unstable compound. That for it to stabilize, it has to excite and relax. That relaxing is what causes that glow you see. So without that interaction, there will be no reaction. So if you want to, maybe the way they sell the glow stick, the way you can see the picture, they sell it as a tube that has something inside. So for it to react, you have to activate it for the glow to come. So the essence of the class for you to understand the chemistry behind glow. Whenever you see glow, see if you go to a big club, as you see them, at times you see a sign of glow coming from somewhere that you cannot see light, but there's a glow. Okay, look at this. Look at this stuff you can see here. You can see this something like this. You can see that since this particular part that wrote work, you can see something like that is like have different colors. That's example of glow. You can see how it's emitting. There's no light, but there's a glow. It's not like banga that sparks light and stops. No. And this glow stick is something that can start for some light for long. Like if you have this glow and you want it to stay longer, either you put this tube inside something like warm water to make sure that reaction is continuous. Okay. Or I don't want this, I want to see use the glow the next day. I can put it inside fridge to make sure that everything is preserved. The next day, then I can activate it in warm water. It starts glowing again. So it's not like Banga. It's different from Banga. Okay. So this is a reaction of the glow stick. Okay. This is my peroxide reacting with phenyl oxalate. Then they form a compound. Look at the compound we're talking about, which reacts with this dye. Now, when it reacts with the dye, it produces CO2 that get excited. When it relaxes, it emits the light. So that's the chemistry of glow stick. So ask your question. As I said, it's going to be a short class because we are just dealing with like few slides. So in summary of glow stick, the chemistry of glow stick is chemiluminescence. It's have 3 components: hydrogen peroxide, phenyl oxalate ester, and fluorescent dye. So what happens is that when this peroxide is broken, when both reactants, that's peroxide and oxalate, mixes together, they are going to form an unstable compound or an intermediate. So that intermediate, whenever a compound is an intermediate and is unstable, it has to stabilize. So stabilizing, they're going to emit CO2, then and energy. Then when that energy relaxes, it emits light, which is seen as glow. So that is the chemistry of glow stick. That's how it works. And we talk about what are the uses of glow stick. Why? Okay. So ask your question for now.
Okay, ma.
I think in the last class we didn't talk about the uses of anthraquinone. Okay, but in today it has been pointed to you that you should know that anthraquinone is a major component of your aloe vera, which is very useful and have its own side effects. I don't like noise. I don't like noise. I don't like noise. I don't like noise. Ask your question. Adesanya, if you're asking question, if you're not asking question, mute yourself. I don't like these people making noise. Any question or you mute yourself, please. Adesanya,
Yes, ma.
I want to ask questions.
Hello, ma.
I can hear you.
So my question is that concerning this glow stick that you're talking about and the reaction that takes place, do we have probably like noble gases that we also present there that will be present to help ignite the glow, I mean the lights or something like neon and other noble gases that might aid?
No, sir.
Right.
No, sir. There is no noble gases. The only gas that will be released is CO2 and energy. And when that energy relaxes, they emit like glow. So there is nothing like noble gases. It's only CO2 that is a gas that will be released. From the reaction, look at your reactant. It's a reactant that determines your product. Okay? So there's no noble gases, only CO2 gas. The dye is what is initiating the glow. See, now the color of the glow is determined by the color of the dye. So when that light is emitted and relaxes, that dye, you can see plus dye, that dye is what is going to induce the color of the glow. Okay, but when it relaxes, it emits light. Then the dye is going to induce the color of the glow of the light. So there's nothing like noble gas. Any other question? So your class work on this, can you take it down? Take it down. No, we still have from now till 12. So the remaining hour time, you're going to use it to do your classwork and submit it. Question number 1. What do you understand by the term glow stick? Number 2. What is the chemistry? The chemistry of glow stick is known as dash. The chemistry of glow stick is known as dash. That's number 2 question. Number 3. List the components of glow stick. List the components of glow stick. Number 4. Explain the chemistry of glow stick reaction. Explain the chemistry of glow stick reaction. Please, Cosrep, you are going to share these questions on the platform so I can add them to the Google Classroom. Okay, and last on this.
Sorry, ma, can you repeat the third question?
I don't know the one that is third question.
Sorry, ma, please, can you the last
the third question is list the components of glow stick.
So now this is number 5, right? Number 5.
Yes, ma, number 5.
List three uses of glow sticks and 3 uses of anthraquinone, respectively. 3 uses of glow sticks and anthraquinone. That's number 5 question. So share it on the platform so I can put it on the Google Classroom. Remember the rule. This question is what you can solve in 10 minutes. So I'm going to give you 12:10 for deadline. I want somebody to come and tell me that at least 20 minutes.
Ma, please share
I got
the
the
Google
first
link.
question, second, third, but I didn't get the fourth. I got the last one. Sorry, ma.
No worry. I think some people got it. Cosrep to share it on the platform. You get others.
Number 1, what do you understand by glow stick? Number 2, what is the chemistry of glow stick called? Then number 3, list the components of glow stick. Number 4, explain the chemistry of glow stick reaction. Then number 5, list 3 uses of glow stick and 3 uses of anthraquinone.
Okay, thank you very much for being able to catch up with all the questions. Please, let's submit it by 12:10. You will not be able to submit it again. By 12:10. So make sure you start working on your classwork like we normally do and submit. Nobody should come and tell me I cannot. If you cannot submit on your own, look for somebody that is not in the class to submit for you. Thank you very much. Please share the question now so I can put it up on Google Classroom. Share the question on the platform. Thank you. I wish you the best. We'll be planning for tests. As soon as Prof is done with her own part, you're going to have a time for tests. Please, I would have employed you to make sure you are acquainted with every classwork you're giving. Don't cram, understand them, because they may not come word to word the way it was presented. But if you understand the question and you're the one that solve it yourself, even if the question is paraphrased, you'll be able to deal with it. I wish you the best. Bye.
No, I don't know. Let's Yeah.